and welcome to chemistry. Thank you all so much for the work you have been sending me. I'm sorry that I've not been getting back to you straight away, but looking at the work you've done, what I am going to do is we are going to do the test next week, because quite frankly I think we're all ready to move on a topic, and also I'm going to revise this with you. Okay, so when we all get back together, I'll do some lessons on it together, because I can see there are some things that I need to talk over with you and spend some time with you guys, not just on a video, but doing it with you. So we will spend a bit of time revising, probably in November, just before your mocks, fingers crossed. So yeah, but anyway, revision. I have emailed you all this sheet, okay, which is exactly what you need to know. So for revision today, I'm going to go through each one of these. Feel free to skip to the part that interests you, and of course, if you're not doing the higher tier, skip all of that bit. Then we are going to go through the questions I've emailed to you. Now, I have printed these out for ease of reference. But if you would rather have it on the computer screen and do it in a book or a piece of paper, that's absolutely fine. There's no need to print it out if you don't want to. I will be going through the answers, so I'm not going to ask you to email me stuff from this unless you want to, but do email me if there's actually, please can you explain this bit again, okay? I am doing this with my teenage son, who hasn't had to study any of this yet. He's not in year 10 yet. So if I say anything that he's like, what, that makes no sense, he's going to tell me, okay? So I'm hoping he's going to be honest, because he might be like some of you going, hang on a minute, I don't get that. So as I say, I'm hoping he's going to be really honest so that we can make a really helpful revision video. Okay, so first thing I want you to do, calculate the relative formula mass given relative atomic masses. Happy days. So if we remember, on our periodic table, we have got an element, and I'm going to do carbon, mostly because carbon comes up a lot, but also partly because that's the first letter of my name, so I'm a bit fond of it. Okay, so on your periodic table, it looks a bit like this. You've got the number 6 underneath, that's called the proton number, which is, amazingly enough, the number of protons that atom has. Oh, aren't we all shocked? Then we've got the mass number up here, number 12, which is the protons and neutrons. Okay, so if we've got 6 protons, 12 minus 6 is 6. So logically we have 6 neutrons in that carbon atom. Don't worry, that's not on this topic. It's just always worth revising. So this is our mass number here. This is the number that we care about. So we need to calculate relative formula mass given relative atomic masses. So we know this. So if you remember, if we were looking at CO2, we've got our mass number for carbon and oxygen. We have got 1 carbon and 2 oxygens, our mass number, and then we just add all of that together. So 12 plus 2 lots of 16, which gives me 44. It's, you know what, you guys have been doing this. You guys, we started off with this being a bit difficult, but you practice this every lesson, and this is something that, what I can see is pretty much everyone can do this. I'm really proud of you. You can do the first part of it. So well done. Okay, calculate the formula of simple compounds from reacting masses, the empirical formula. Okay, you read it in your head. You don't have to do the in your head. Okay, so empirical formula. That's the smallest formula that makes sense. Okay, so you are given numbers. And you know what, you can highlight these, you can underline them, you can... I like to write them out because I always miss it otherwise. So we can say 127 grams of copper reacts with 32 grams of oxygen. Great. So then I can say I have got, always, first step, look up what your atomic mass is. and write that down. There's usually a mark for that. Not always, usually. Okay, so you've got 63.5 and you've got 16. Okay, and then you write down the information you've got here. We've circled it. We know that's our copper, that's our oxygen. We've written it down. Okay, then we always divide mass by the AR. Okay, mass always goes on top because it's massive. Can't think of an easy way to remember that mass goes on top. Just remember it. I don't know, sorry, that's not very helpful, is it? And in this case, we get an exact 2. We then divide it through by the smallest to find our ratio. So 2 divided 2 gives you 1. So the formula has to be 1 copper to 1 oxygen. So CuO, and we never write the number 1 in chemistry because, quite frankly, it's confusing enough with a capital I and a lowercase l. We don't want a 1 in there as well. So if you're struggling with this, please do go back onto the video where I explain it all, because I know I did some more examples. So you also need to deduce the empirical formula of a compound from the formula of its molecule. That's this bit here. So a compound has an empirical formula of this. That's the easiest possible formula it could be. That's cancelling out all the numbers. Okay. So then we figure out what the molecular mass is, and we do the same thing. We do carbon, hydrogen, oxygen. We've got 1, we've got 2, we've got 1, and we've got 12, 1, 16. So this is going to be 12 plus 2 times 1, which is 2, plus 1 times 16, which is 16, and that gives us 30. Okay? Then we find out that the actual compound has a molecular mass, an MR, of 180. What is the molecular formula? So we need to figure out how many 30s go into 180. Now, all right, I'll give you a hint. With chemistry, it's always timesing and dividing. Have an idea in your head that this has to be a number bigger than 1, because it can't be half. You can't have half a carbon. That would just be silly. So it's going to have to be a number bigger than 1. And you've got to do some sort of timesing or dividing. Okay, let's try dividing 30 by 180. You get 0.1. Oh, no, that can't be right because it's less than 1. Okay, let's try 180 divided by 36. 6 is a sensible number. I'm going to go with that. So you don't actually have to know the chemistry. Bit of a hint for you. You don't have to know it. You just have to remember it's all about timesing and dividing and getting a sensible number. Okay, I don't normally say that, but I know most of you aren't going to want to continue on with chemistry beyond GCSEs, so I just want you to get as many marks as you can. Think of what a sensible number is, and if you get it, you've done it right. But anyways, how many 30s go into 180? That's what this question's asking. And we know that there are 6 30s in 180, whether you can do the maths or not, okay? So that means we just have to times all these numbers up by 6. So 1 times 6 is 6. 2 times 6 is 12. And 1 times 6 is 6. So there you go. And that's the formula for glucose, which is used in photosynthesis. So hopefully that's made some sense of that. Okay, so describe an experiment to describe the empirical formula of a simple compound such as magnesium oxide. Now we've done this one, okay? This was the one where we took the magnesium, yeah, and we rolled it into a coil and we popped it on a crucible and we kept on lifting the lid until it had turned into that white powdery stuff, which was magnesium oxide. Yes? So we did that and we weighed the magnesium before and after, and we weighed it in the crucible, so we had to take off the mass of the crucible. So you've done that. Hopefully you've got your books and you can revise this. If not, it is on the electronic textbook. Look it up. There are lots of videos showing you this. I can't actually show you this. I don't have the magnesium and the crucible and the Bunsen at home, which is, even if I did have the Bunsen, I don't have the gas outlet for it. Okay, so what you do, you get the magnesium, you pop it in the crucible, you measure the mass. Sorry, you measure the mass of the crucible, then you do the magnesium in the crucible. Then you heat up the magnesium, taking care that it doesn't burn. So you need to do that lid lifting thing really safely so you don't get burnt. And then when it's all reacted and cooled down so you don't get hurt again, you then take the mass of the crucible and the magnesium oxide. Now that difference in mass has to be the amount of oxygen that was added. And so that's that will help you. So what I'm going to do is we're going to just take a look in the book, and I am going to go through the how to do that. Okay, so I'm going to do this upside down just because my son's filming it and it's easier for him. So, okay, we had 30 grams for the crucible. Okay, and then I added my magnesium, which was 32 grams crucible and magnesium. Thank goodness I can write short things for the magnesium. Okay, so that means I must have had 2 grams of magnesium. So let's pop this down here. So that's that mass. We also need to know the AR. Remember, I say we always need to know the AR. So we look it up on our periodic table and we find it's 24. Okay, we're going to make magnesium oxide. So we're going to add oxygen, and we know the AR for oxygen is 16. But what's the mass of oxygen that's going to be added? So we're going to do our experiment. We're going to do our little crucible, and we're going to lift up the top and go, ooh, no, it's not quite done. And we're going to put it down and lift up the top. And, ooh, is it done? No, it hasn't. Put it down, and so on and so forth. And then we are going to let it cool down, and we are going to take the mass. And the mass is going to be, just let me have a quick think. The mass is going to be... Okay, so I do my experiment, and it turns out that I have made 33.3. Let's do all the threes, and that's crucible and magnesium oxide. Now you'll know I've put the X and the Y because I don't actually know that it's MgO. It could be MgO5, it could be Mg3O, it could be anything, who knows? We're going to find out. The numbers will be given to you in your test if they ask you about this, okay? So, 33.3 grams minus 32 will give us the, so I've made 3.3 grams of magnesium oxide because that's minus the 30. But I only want to know about the oxygen, so I'm going to take off the magnesium as well. So 33.3 minus 32 gives me 1.3. Okay, sorry, doing this upside down. Next thing is mass over the AR, which gives you something called the moles. Again, you don't need to know it if you're not higher tier. So on my calculator, 2 divided by 24, do it on your own calculator as well, is 0.83 recurring. 1.3 divided by 16 gives you 0.83. oh sorry, this was 0.083, wasn't it? 0.08125. Okay, now some of you will look at that and say, but they're almost identical, that's 1 to 1. Good for you. But they're not all as easy as this, so we're going to prove it. Okay, we're going to divide by the smallest. Okay, which is 0.08125. So, divide 0.08125. Okay, so that's going to get me as 1, because anything divided by itself is 1.